Well, good morning, Mr. Eicher here, bringing 2006 number 4 FRQ and AP statistics to you. Let's walk through this question and talk about scoring and the solution and stuff like that. If you haven't read the question, go ahead and pause the video and read the question. Some important terms I'm going to highlight. First thing, I notice that we're working with means, not proportions. That's really important. Means, not proportions. And also, we have a random sample of 150 patients. And then we have a table. This is not a two-way table of categorical data. It is a table that shows summary statistics. We have a mean and standard deviation of wait times. We have sample size. And I see that the sample size is broken up into two, it looks like independent groups, whether the person with heart attack symptoms who had reported to the emergency room, how they got to the emergency room, either by ambulance or driving themselves. Also, I see that we're working with a 99% confidence interval. That means we don't have to write hypotheses, we don't have to do a significance test, and we're looking for the difference in means. So difference in means. If this were a hypothesis test, we would have, for instance, like mean of ambulance minus mean of self-driving, that kind of thing, but we're not going to do a significance test. This is the difference in means that we'd like to estimate. That's the unknown difference in means. So we're doing a confidence interval and we're working with means. Maybe we'll jump over here to the formula sheet, and on the second page are your sampling distribution formulas. All of these are proportions, so we're going to ignore those. We're working with means. And we have two different groups, two independent groups, either the ambulance arrival or the self-driven arrival. And notice this formula here is our standard error of the statistic. Since we don't know the population standard deviation, we estimate it with the sample standard deviation and then square it to make it variance. And if you don't remember the formula for a confidence interval, it is this formula right here. Our statistic will be our difference in means, critical value, T star, and our standard error of the statistic was on that previous page I just showed you. So first thing, we would like to use the correct formula. So we want a confidence interval for two samples with means. So that would be, we're going to use a two sample T interval on the calculator. That's called a two samp T int to estimate the difference in mean wait times. And we're going to do ambulance minus self, so A for ambulance, S for self. Before we do this, we want to make sure that the conditions are met. So we have R, I, N, G. Now in this question, it said we had a random sample that we separated into two groups, and those are independent groups. A random sample of 150 separated into two groups. It's a little more common on the AP exam to have separate random samples. So a random sample of those who arrived by ambulance and then a separate random sample of those who drove themselves. So typically you would have plural here, random samples, and that would be really important. If you're told in the question that you had two random samples, then when you check conditions you need to address that you have two random samples. For the independent condition, we need to assume that the population of those arriving by ambulance is 10 times the sample size, so 770. And then those arriving by driving themselves is greater than 10 times that sample size, 73, or that group size. And then to check the normal condition, both groups are greater than 30. So that's 77 is greater than 30. 73 is greater than or equal to 30. So our sampling distribution of x bar A minus x bar S is roughly normal. This part that I said here, the sampling distribution of that statistic is roughly normal. It's not required when you check conditions, but if you understand that, if you think you can get that right, then I encourage you to include it on your test. That would be kind of a smiley face, maybe a rounding up issue if you could say that correctly. However, if you say it incorrectly, it would be a rounding down issue, or you could lose points. And then finally, the two groups are independent. Two groups are independent. They're not dependent, they're not paired in any way. So those who arrive by ambulance are different than the people who arrive by self. They're independent groups. So all of our conditions are met, so we'll use a two-sample t interval. The formula for a two-sample t interval is your difference in sample means. So I'll do 6.04 minus 8.30. That's our statistic. So it looks like people by ambulance get there 2 minutes faster, 2.5 minutes faster on average. Plus or minus our t critical value times the variance for ambulance and the variance for self-drivers. And then to get this t star, I would like to use the calculator to get t star. So let's take a minute, encourage you to pause the video and see if you could find the right function on your calculator and type the numbers in right, and we'll get the interval. I'm going to calculate this by doing a two-samp t interval. We have ambulance information I put first, and then the self information I did next. Make sure for the confidence level you do 99%, and then we always say no to pooled. We don't know that the population variances are the same, so we say no, don't combine the sample variances. And I get this answer, -4 to -0.2, and I get this degrees of freedom, 140.4. So that's the degrees of freedom I'm going to use just to make sure everything's accurate. Degrees of freedom is 140.4. So to find our t star, we have inverse t of 0.995 with degrees of freedom 140.4. Remember to add the tail area on the left so that the function works correctly on your TI calculator. So inverse t 0.995, 140.4, and we get a t star of 2.611. Our interval -4.3, we'll call it, to -0.23. And these units are minutes. A lot of students will stop there and not get full credit because we have not interpreted the interval. This was an older question from 2006. Seems like the AP exam writers are a little bit nicer to tell you in the language. They would say like construct, which we've already done, and interpret, just to be more clear with the directions. They did expect you to interpret it here in part A, but it didn't say it explicitly. Just like checking conditions, you need to remember to check conditions. So likewise, you need to remember to interpret, but nowadays they might even underline and just to really reinforce, don't forget to do both. So to interpret this, we would use the context that they so nicely said in the question. So we would say we are 99% confident that this interval captures whatever we're trying to estimate. The unknown, I like the word unknown. You could also use the population. The unknown difference in means. Notice means are plural here, or mean weight times is plural. For ambulance, transported patients, and self-transported at this ER. This doesn't apply to all ERs, it just applies where they selected the sample, which is at this ER. So this was scored if you check the conditions correctly and correctly identified the interval, either by the name of the interval, which we did right here, or by the formula of the interval, which we did right here, so we're double good, then that would be an E. If you got the formula correct, got the interval correct, with the degrees of freedom, that would be an E. And then if you interpreted correctly, you mentioned the confidence, you included the interval, you talked about that it's referring to a population, the unknown. It's not the sample mean difference, it's the population difference in means. And then in context, preferably present or future tense, which we didn't have that issue. We didn't say like people who were transported. That would be a problem because that's referring to the sample. Wait times for ambulance transported patients and self-transported patients. Sounds present or future tense enough. So this first part, part A, would be worth 3 out of 4 points. Areas that students would miss. Sometimes students might not get this formula. They might miss the T star. They might not remember to check conditions at all. That would be missing a point. Not using plural. In this case, you wouldn't have to, but oftentimes with two sample tests, you have plural samples would be required. Maybe students mix up the independent and the normal condition. A lot of times in the interpretation, they mention something like forgetting to mention unknown or the population difference in means. Or more commonly here, they would say something like mean wait times for people who were transported, past tense, and that would knock you down a level because we're looking for the unknown population difference in means, not the known sample difference in means. And then the last part is worth its own point. Based on this interval, do you think the difference is statistically significant? This is basically asking you to use your interval to conclude a test. So based on this interval here, and as it says, based only on the interval, I would encourage you to rewrite the interval that you had earlier and then state something like, since 0 is not included in this interval, we have, so look, I'm answering the question. Yes is basically saying we have statistically significant evidence of a difference in mean wait times. I'll even draw you a picture. Pictures can be really helpful to explain to the reader. Here's 0. This would be that there's no difference in mean wait times. Our entire interval is here, so the entire interval is below 0. So 0 represents that there's no difference. The entire interval is below 0. That means there is a difference in mean wait times. Let's talk about scoring. It's really common for students just to say this much. They might say, yes, 0 is not included in the interval. Oftentimes the scoring wants a little bit more context. So that's why I said we have statistically significant evidence of a difference in mean wait times. And I've also mentioned the context here, stating that 0 represents that there's no difference. The entire interval is below 0, so we do have evidence of a difference, since 0 is not included. Thank you for watching this video. Hope that was helpful. Let me know if you have any questions, and I'll see you in the next video.